Welcome back. In this video we begin Chapter 3, Derivatives, and 3.1, Introducing the Derivative. This is where calculus really starts to take off. We'll spend 2 lessons on 3.1, and so today we'll discuss the derivative at a point. So Chapter 3, 3.1, the derivative at a point. Suppose that the blue curve to the right, maybe that's the graph of a function f. And we see that at x equals 2, there's a tangent line. The line is tangent to the graph of the function at x equals 2. Also, can you tell what the slope of that line is? The slope of that line, the slope of that tangent line is 1/2. You might be able to identify a few lattice points on that line and see that I have a change in x and a change in y. My change in y is 1, my change in x is 2, so the slope, which is change in y over change in x, equals 1/2. And we have this notation, f prime of 2 equals 1/2. So the f prime is telling me the slope of the tangent line. In general, f prime of a means the slope of the tangent line to y equals f of x, where x equals a. Here are 2 examples. In the example on the left, the tangent line occurs when x equals -1. Also, what is the slope of that tangent line? Can you see? It looks like the slope is maybe -2. So we will write f prime of -1 equals -2. The tangent line touches the curve right when x equals -1, and the slope of that tangent line is -2. How about the example on the right? The tangent line touches the curve when x equals 0, and the slope of that line is 1. So we write f prime of 0 equals 1. We use the word derivative to indicate slope. So for the picture on the left, we would say the derivative of the function at -1 is -2. And for the function on the right, we would say the derivative of the function at 0 is 1. This is what we mean by the derivative at a point. In this figure, the graph of a function is shown, and I can pick different x values, and it'll tell me, the computer will tell me, the slope of the tangent line for that particular x value. So for example, when x is 4, I see that the slope of the tangent line is 1.32. As I move to the right, we see how that slope is changing. And when I get to x equals 5, I have the slope of the tangent line is 0.2. It's just a little bit positive. So really think about that f prime notation. F prime of 5 equals 0.2. Let's take it over to 6. F prime of 6 is -0.77. And we can see that the tangent line has a negative slope there. So how do we actually compute f prime of a? How do we figure out the slope of a tangent line? Well, we do 2 steps. Number 1, we make a formula for the slope of a secant line. That's a line that goes through 2 points of the curve. And then we take a limit to turn the secant slope into a tangent slope. Here's what I mean. We actually have 2 methods for doing this. So here's method number 1. I kind of think of this as the x approaches a method. The slope of the secant line on the right, can you see what that is? It goes through 2 points. It goes through a point on the bottom, which is a, f of a, and it goes through the point on the right, which is x, f of x. And so the slope is change in y divided by change in x. But what is that change in y and change in x? The change in y is going to be f of x minus f of a, and the change in x is going to be x minus a. So we get change in y over change in x, which is my f of x minus f of a over x minus a. So that is the slope of the secant line. And then we take the limit as x approaches a. So I imagine on the bottom of that graph, x approaching a. X gets closer and closer and closer to a. And as x approaches a, this point on top will come down and approach this fixed point above a, and the secant line will turn into the tangent line. Here is an animation of that. X is approaching a, and the secant line is turning into the tangent line. Right there. And that's what's being expressed. The slope of the tangent line is the limit of the slopes of the secant lines. So here is our formula for our method number 1 formula. F prime of a equals the limit as x approaches a, f of x minus f of a over x minus a. Let's use that formula, and we'll apply it to the function f of x equals x squared plus x, and we'll compute f prime of 3. Well, according to my formula that's boxed up above, f prime of 3 equals the limit as x approaches 3 of, now let's see, f of x, so x squared plus x minus f of a, so in this case my a is 3, so 3 squared plus 3, all that divided by x minus 3. Alright, let's work that out. So I'll keep writing the limit, and let's just simplify the fraction. So x squared plus x minus, and then 3 squared plus 3, 9 plus 3 is 12, and that's all over x minus 3. So we've seen limit problems like this before. How do I evaluate it? Well, the first thing I do is I ask, can I actually plug in 3? And no, I can't. If I plug x equals 3 in, then I get 0 in the denominator. So the next thing I say is, can I factor the numerator? And yes, I can. Limit as x goes to 3, and this turns into x minus 3, x plus 4 in the numerator, x minus 3 in the denominator. And I have two factors that cancel. So we get the limit as x approaches 3 of x plus 4. And now I really can plug in 3, and I get 7 as my answer. So it turns out, in this graph, if I were to draw that tangent line in there, that tangent line has a slope of 7. Here is method number 2 for computing the derivative at a point. I call this the h approaches 0 method. So as before, we have our point A that we want to figure out the slope of the tangent line. So I'm going to pick some point to the right of that, but I'll say that it is a distance of h to the right. And so instead of labeling it x, I can just label it a plus h. Now what is the slope of the secant line? Well, now my change in x is pretty easy. The change in x is simply h. And the change in y is f of a plus h minus f of a. So that's what I have in my expression on the left, change in y over change in x. So this is the slope of the secant line. How do I make the secant line approach the tangent line? I just make that h shrink down to 0. And as h shrinks down to 0, that point on the right will come in and get closer to a. So f prime of a, that is the derivative of the function at a, is the limit as h goes to 0 of the slope of the secant lines, and that will give me the slope of the tangent line. So here is this in action. H is shrinking to 0, and as h shrinks to 0, that point on the right sneaks in to coincide with the point A. And throughout this process, the slope of the secant line is f of a plus h minus f of a all over h. So that quantity, it changes and it becomes the slope of the tangent line. Again, let's apply this method to that same problem we had before. Remember, so this is exactly the same function. It's the parabola that goes through the origin. I'll pick my point 3, and I'll say, how can I figure out the slope of the tangent line? So we'll use method number 2. Alright, so f prime at 3 is the limit as h goes to 0. F of, now I'll just substitute a, so I really want 3 plus h minus f of 3 all over h. Alright, let's substitute what that really is. So f of 3 plus h. So be a little bit careful. This is where some algebra errors can occur. F of x is x squared plus x. So f of 3 plus h is 3 plus h squared plus 3 plus h. And from that, I will subtract off my f of 3. f of 3 is 3 squared plus 3. And that's all over h. Alright, I'll keep writing limit. I'm not actually taking the limit, I'm just simplifying that fraction. And let's expand the numerator. So we get 9 plus 6h plus h squared. That's just using FOIL on that square to expand it out. Plus 3 plus h. Now I will add 3 squared plus 3 to get 12 and subtract the 12. And this equals the limit as h goes to 0. Let's see, in the denominator I have h. And the numerator, let's see, I have an h squared. What about my h's? I have a 6h and a single h, so that means I have a plus 7h. And the numbers fall away. I have a plus 9, a plus 3, and a minus 12. So the numbers fall away. So look at this. I can factor in h out of the top. The limit as h goes to 0 of h times the quantity, h plus 7 all over h. h's cancel. So this is the limit as h goes to 0 of h plus 7. And now I really can plug in 0 for h. And I get 7, just like I did before. So there you have it. We have seen two different formulas that help us compute the slope of a tangent line to a curve. That is the derivative at a point. And this is a good place to stop.